Students, the chapter that we are going to do today is number system, right? Earlier in history there was a huge debate as to what all numbers should be included in the number set, right? Babylonians, they were debating whether to include 0 as a number or not. The point that they were making was, how can we give value to something that is equal to nothing, right? But later 0 was included in the number set, right? Now all the numbers that were similar in some sense, they were classified under one category, right? Similarly, all the numbers that were similar in some other sense, they were classified in some other category. Now this categorization of numbers was done so that it was easy for us to study the numbers individually, right, in their particular classification only. Now let us start with the chapter and let's see what we are going to do in this chapter. First we'll be dealing with the classification of numbers. As I already told you, we'll be learning all the categories in which the numbers can be classified. Next, we'll be talking about the decimal expansion of numbers, right? In this particular topic, we'll be learning how to define these categories that we learned in the previous topic in a better way or in a new way, right? Then we'll be talking about what is a number line and how to represent different kinds of numbers on the number line, right? At the end, we'll be dealing with some operations on real numbers, right? And then we'll talk about rationalization and laws of exponent, right? Rationalization is nothing but when we make the denominator a rational number, that is rationalization. We'll be talking about this topic in detail when it comes to us later, right? So let us start with the chapter. Now what is a number, right? Or what is the purpose of a number? Number is nothing but a tool. What is a number? Number is a tool which helps us to count. So I can write that what is a number? Number is nothing but it is a tool. It is a mathematical tool which helps us to count, right? So let us start with the categories of numbers, right? The number system, it can be classified into these categories as you can see in the PPT as well as on the board, right? The first category is called natural numbers, the second one is whole numbers, the third one is integers, and the fourth one is rational numbers, and the last one is irrational numbers, right? There is one more category to it which are called as imaginary numbers. Imaginary numbers, right? But these numbers, imaginary numbers, they are out of the scope of our portion, right? So we'll be talking about these numbers in higher classes but not in this class, right? So we'll be basically dealing with the rest 5 numbers in this particular chapter or in this particular class. So let us start with the first number, that is natural numbers, right? So what are natural numbers? Numbers that start from 1 and go up to infinity, right? I'll be using this term infinity time and again. Infinity. Now what is infinity? Infinity is not an absolute number, it is nothing but a relative term. Infinity means very, very, very large number. You can add as many you can add here, very, very, very large number, right? And it is not an absolute term but it is in relative term. This is a relative term. I can't say that infinity is a number, but I can say that some number is infinite times larger than some other number. That is why we call this as a relative term and not an absolute term, right? So we were talking about natural numbers. So let me write here, natural numbers are numbers which start from 1, 2, 3, 4 and they go up to infinity, right? And the natural number set, it is denoted by n. The natural number set is denoted by n. N stands for natural number, right? Here you can see that which is the smallest natural number. You can clearly say that 1 is the smallest natural number, right? Now let us talk about another set which is called as the whole number set. Now there is one more term called set. You might be wondering what is a set, right? Set is nothing but a collection, right? I'm going to call a collection as a set. So set is nothing but a collection. So when in this chapter I'll be using this term set, I'll be referring to a collection of numbers, right? So now we'll talk about whole number set or the collection of whole numbers, right? So whole numbers are nothing but when 0 is added to the set or the collection of natural numbers, then the set or the collection that we get is nothing but the whole number set, right? So what I simply mean is, if I start writing the numbers right? And my first number is 0 instead of 1, 0, 1, 2, 3, 4 up till infinity, right? So if my first number is 0, right, if I start writing my numbers from 0 instead of 1, then the set or the collection of number that I am going to get is called whole number, right? So whole number is denoted by W. Whole number is denoted by W. W stands for whole number, right? So here you can see one definition, set of natural numbers plus 0, right? So whole number is nothing but the natural number set, and if we add 0 at the front or at the beginning, then we are going to get the whole number set, right? And it is denoted by W. Now let us talk about the next set, which is integer set, right? So what are integers? Integers are nothing but when we take the natural number set, the whole number set, or let us say the whole number set, and take the negative numbers as well, right? If I simply write the integer set, it will be 0, 1, 2, 3, 4, so on up to infinity, right? This is nothing but the whole number set, right? And if I multiply each and every natural number by 1 and place them here, right, then I am going to get an integer set. So let me write minus 4, minus 3, minus 2, minus 1, comma 0, right? And this goes or extends up to minus infinity, right? Minus infinity is nothing but a term which is very large in negative sense, right? A term which is very large in negative sense, right? So from minus infinity to plus infinity, all numbers of these kind, they are called as integers, right? So whole numbers plus the negative forms of natural number, this whole collection is called as integer set, right? Now you must be seeing that integer set, it is denoted by Z, right? Integer set is denoted by Z. Now you might be wondering, why do we denote integer set by Z and not by I, right? Because this set was found out by Germans, right? And Z, it stands for Zahlen, right? Z stands for Zahlen. I beg your pardon, this set was found out by this was found out by Germans, and Zahlen is a German word, which means, Zahlen means to count, right? So Z stands for Zahlen, which means to count. So this Zahlen is a German word which stands for counting, right? So that's why integers set is denoted by Z. Now let us move on to the next set. Now rational numbers, this is a very important topic of this chapter, because we'll be mostly talking about rational numbers and irrational numbers in this chapter, right? So what is the definition of a rational number? As you can see in the PPT, a number which can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. So let me write down the definition for you, right? A number which can be written in the form of P divided by Q, where the condition is that Q should not be equal to 0, right? The denominator of this expression should not be equal to 0. This Q should not be equal to 0, right? Now why is it so important that the denominator should not be equal to 0? Let us see. Now if I give you a question, you have to identify that by this definition which all numbers are rational numbers. So our first question will be, identify which all numbers are rational numbers. So my first one is, let's say 5, second number is, let's say 0, third number is 1 by 0, and fourth number is minus 3 by 2, right? So these are the four numbers, right? And we need to identify which of them they are rational numbers or they satisfy this particular definition, right? So let us start with the first one, that is 5. As you can see, number 5, right, it can be written as 5 by 1. Why? Because any number which does not have a denominator, we can write 1 as the denominator for that number. So 5 can be written as 5 by 1, right? So let us verify with the definition. The definition says that any number which can be written in the form of P by Q, right? Now 5 can be written as 5 by 1, right? both P and Q should be integers. There is one more condition here, P comma Q, they are integers, right? Both P and Q should be integers. So I can see that 5 and 1 both are integers, right? And the denominator should not be equal to 0. As we can see that 1 is not 0, so this is a rational number, right? I can put a tick here. This whole 5 is a rational number, right? Now let us deal with the next number, which is 0, right? So 0, even 0, it can be written as 0 by 1, right? Even 0 can be written as 0 by 1 because a number which does not have a denominator has the denominator 1, right? So let us verify with the definition. Both P and Q should be integers. 0 is an integer, 1 is also an integer, right? And the denominator should not be equal to 0. As we can see that we have a 0 but in the numerator, right? And the definition says that the denominator should not be equal to 0. So here we can see that the denominator is 1, so 0 can also be considered as a rational number, right? And the next number or the next expression is 1 by 0. So let us find whether it is a rational number or not. Talking about 1 by 0, right? It has a numerator, it has a denominator, right? So let us verify with the definition. Both P and Q should be integers. 1 and 0 both are integers, right? And the denominator should not be equal to 0, right? But here you can see that the denominator, here the denominator is equal to 0, right? Now what is wrong with the denominator being equal to 0? Any number which is divided by 0, it becomes a very large term. We often call this as not defined or infinity, right? Any number which is divided by 0, it is called as not defined. We don't define it, right? It is indefinite or not defined, right? So any number which is divided by 0, we don't consider it as a number. It becomes a very huge term, right? So this is not satisfying the definition. So I can say with certainty that 1 by 0 is not a rational number as the denominator was equal to 0. Now let us take a look at the next one. These are very simple questions. You might even see the question and you might be answering the question without even solving it, right? So just for clearing the basics, I am solving each and every question. Minus 3 by 2, right? So minus 3 by 2 is already written in P by Q form, right? Where both minus 3 and 2, right? Minus 3 is also an integer, 2 is also an integer, and the denominator is not equal to 0. So I can say that minus 3 by 2 is also a rational number, right? So we have talked about natural numbers, whole numbers, integers and rational numbers, and we have found out which numbers are rational and which are not rational. We'll be talking about irrational numbers. That was the fifth type of category or the fifth classification later. First we'll be dealing with some operation on rational numbers.